Alright, here's what it looks like once you have simplified all of your externals to one force on a simply supported beam. One last time. See if we can get the animation to play or the slideshow to play. Again, this is showing lines of force that would be unknown to start but known on the right side. This would be a pin joint and a roller joint. This force would have come from any set of applied forces from the beginning. Let's see how it works. You have a beam subject to a force. On the left, you have a pin joint. On the right, a roller joint. A roller joint is showing a direction normal to the point of contact, which is up. Therefore, you can then solve a point of concurrency with two of the forces. You know it's a three-force two-dimensional problem. Therefore, you know that the forces must be concurrent. That means you could actually skip all this, put in basically some information and solve this using algebra. But why would you when you already know you have two forces there that are concurrent? Therefore, the third force has to be concurrent. You then can go to that point of solving a concurrent force problem. You slide, all the vectors have to kind of emit from the line of point of concurrency. You slide one direction, so you've picked a direction home. We're going to come home going straight up. Therefore, you had to go from the end of one vector to that straight up path along that direction. You sketch in your two forces, and then you slide them back. And realistically, remember, the force can be anywhere in the system, but essentially you have something that looks like that with your system. And from there, you can go about and solve any number of things. Remember, this is just for solving for reactions. In reality, you do want to stick with that matrix method, or realize that once you cut the section, you have to re-add up all the vectors. So this is basically showing you how basically you can get a quick solution, a check solution for a set of concurrent two-dimensional three-force concurrent force problems. Thanks for listening. That's the end of that. Eventually figured out later, if not now, but it is expected that you can do this if you're in an engineering world. Thanks for listening.